Good evening. This is VK3EKH studios of VK3CSJ in Narre Warren South, broadcasting on the prime frequency of 3541 kHz in the 80 metre amateur radio band, and also via the Melbourne television repeater VK3RTV on digital channel 1 HD, and also streaming on my Discord channel, and also on my YouTube channel, which you can find if you type in VK3CSJ in the YouTube search engine and look for the live indication. If our streams don't fall over tonight, we should hopefully be somewhat okay. The Discord stream, if you haven't registered on Discord, just go to Discord, just type in Discord in your favourite search engine and register on Discord. And on my QRZ.com page, VK3CSJ and VK3EKH, I supply a link which will allow you to get to the astronomy chat room and also the HD stream associated with the Discord stream, which is streaming right now. And as I say every week, the advantage of the Discord video aspect is that it's near real time, much better than what YouTube is, because YouTube has that 20-second delay. So if you can put up with the 20-second delay and listen to my gunge on 80 metres, then that's okay then. Anyway, good evening everybody on this 14th of November. Trust everybody is okay, and looking forward to this weekend if you're out and about doing things. The weather should be nice tomorrow. The Bureau is saying that there's a little bit of rain coming throughout the night. But tomorrow should turn out to be a reasonable one. So let's hope it is. Anyway, good evening, and we've just got a few articles tonight, so hopefully we might be able to get out of here under 60 minutes. But I think I say that every week, and I go for another half an hour usually. Anyway, all right, let's go on to the usual thing for those folks that might be tuning in for the first time. Let's see if I can just bring up this one. I'll do this one tonight. This broadcast, of course, is on behalf of the Astronomical Society of Victoria. The VK3EKH is the official station for the ASV, and has been registered since 1988. And has been broadcasting every Friday, well, near every Friday, since 1988. The first 20 years was conducted by Russell Ward, VK3DRW, and then I took over the microphone, I think it was around about 2008, and been doing that ever since. So, good evening to Russell. If you're listening in the background, perhaps, maybe, possibility. We have an email address if you wish to send email on the signal reports tonight, vk3ekh@gmail.com, vk3ekh@gmail.com for any signal reports. Hopefully we should be producing a reasonably good signal. Of these last two Fridays I've been running the linear amplifier at risk of blowing up the modem. So, but the modem seems to be surviving. So anyway, hopefully the signal on 80 metres should be a little bit better than the usual one I've been running for the last few months now. So I'm just risking that. I'm just hoping that the 400 odd watts is not going to upset the modem seriously while I'm broadcasting. Anyway, enough of that. But anyway, so where I was heading to, the ASV is a non-profit society, and for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our two metropolitan locations, the Morley Community Village and the Melbourne Observatory. We host monthly Astro Talks, which was just this week, in fact, at the Herbarium near the Melbourne Observatory. The Society's library is located at Melbourne Observatory and is open during our Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct Astronomy for the People gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. Please check the online calendar on the ASV website for details if you are interested in attending one of these events. The ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope, and also currently working on the installation of a series of remote telescopes at the Dark Sky site at Heathcote, which once complete, and they pretty much are complete now, will be accessible to our members for use. Yes, the ASV is currently involved, I've just said that, thanks to a generous donation of one of our long-standing late respected members, Leon Mao, who donated the Dark Sky site up there to Heathcote to the ASV many years ago, located North Melbourne. Leon Mao Dark Sky site, we call it LMDSS, which of course has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope at the Leon Mao Dark Sky site. Yes. Melbourne Observatory during some, I just lost my place there. During some section meetings, our members' nights held once a month at the observatory. What's not written there is that we also have a fully steerable 8.5 metre radio telescope, a DS Kennedy dish, 30-footer, and that's now fully steerable and controllable by computer, and has a certain amount of remote functionality. And it currently at the feed point has a hydrogen line spectrometer working. So good evening to any RAS guys that might be listening. There's also an annual yearbook which is supplied to members as well, and a bi-monthly newsletter called Crux, which all members are welcome to contribute to. The ASV's logo shows the Southern Cross and the pointer stars, and its motto is "This way to the stars." The ASV is governed by a set of rules which should be read before applying for membership. So if you go to the ASV website at www.asv.org.au, that's www.asv.org.au, under the About Us tab at the top of the page, which is where I'm reading from right now, you will see the ASV rules, which is a separate page. You link on that and go for a good read. And then straight after that is Join Now. The ASV needs you. And then underneath all that is a bunch of past presidents from 1922 to our current president. They're all listed there. So if there's anybody that you might be familiar with, name-wise. In fact, if you look up 1988, where is it there? 1988 to 1989, the president was a K. Harrison. I can't remember his first name exactly what that might have been. It could have been Ken Harrison, perhaps, but his surname was Harrison. And the call sign VK3EKH is taken from that the president of ASV at 1988. VK3EKH, so KH being the president at the time. I think it might be Ken, but at least Mr. Harrison. Just a bit of trivia there. All right. And of course the ASV has several sections, more than several sections in fact. Let me just go back one on that. There we go, that'll do. We have the astrophotography section, probably the biggest section out of all the sections that are available to members. Astrophotography, which meet on a Sunday afternoon once a month. The club section, comet and meteor section, computing section, cosmology and astrophysics, deep sky, historical section, instrument making, so if you want to make telescopes and know how to do that, there is a section for that. Juniors, for the young guys and fellas, lunar and planetary, new astronomers group, radio astronomy, solar astronomy and space exploration. And space exploration is a relatively new section, but it's been going for a couple of years now. If you're into Facebook, if you have a Facebook page, actually I'm not sure if space exploration is a private page or whether it's open. It might be private. You have to be join up, I think. But space exploration is managed by Kate Green, and she's very, very active at producing news articles of astronomy. Almost daily there'll be a swag of news items that she will publish for you to read and catch up with. So there's some very, very interesting articles. I don't know where she digs them up from, but boy oh boy, it's a very active Facebook page from the point of view of being kept informed. So good on you, Kate. All right, so that's about it for the plugging of the ASV. Like I say, any information to do with ASV, just go to the homepage at www.asv.org.au. We're coming up to the Christmas Star Party, actually, which is open to the public to come up and see. And I'm just waiting for the revolving banner here to bring it up. Is that it? No. Where are we? Where's it? There it is. Stop. Okay. So if you go to like I say, the homepage of the ASV, you'll read up on it there. The Astronomical Society of Victoria invite you to our annual Christmas Barbecue 2025. It's Saturday the 13th of December from midday, as it says there, book now. So there's a link to that. Event location, Leon Mao Dark Sky site. For the public, tickets are $20 per adult, $10 for ASV members. Kids are free, under 16 and under are free. $10, 16 and under, ASV members free, including free kids. Astronomy show bag. There's $50 for family ticket, which is 2 adults up to 3 children, something like that. Anyway, have a look at the banner, the revolving banner on the ASV webpage for more information on that. But that's slated for the 13th of December, the annual Starbecue, which is a big event. We usually get anywhere up to 200 to 300 people that roll up, and there'll always be a bunch of telescopes set up in the observation field. You can be sure to be at least anywhere between 15 and 20 telescopes of various sorts, all manned by their astronomer. And if you wish to look through those telescopes and talk to the astronomer that owns the telescope, they'll tell you all about it and how it works. And if you're thinking about buying a telescope, there'll be plenty of information there, and of course a chance to see through the telescope of interest, so you can get a bit of an idea. But hopefully the only thing it's a problem for being an optical astronomer, of course, is the weather. But I can tell you that Melbourne city can be completely covered with cloud, but once you go across the Great Dividing Range, the sky can clear up pretty quickly, and from about 7 o'clock onwards, it'll be clear skies up at ASV, up at the LMDSS site. So invariably, it is a good sky location. Nevertheless, there's your chance to see what's going on up at the Leon Mao Dark Sky site. There'll be various tours that will take you around the site. you'll be able to visit the radio astronomy section. They've got a special container up there, or lab, what we refer to as the lab, and a close-up view of the dish antenna, the dish. So, it's a good to go up there while there's daylight, and of course there'll be there's always just after the they have a food truck that runs up there from about I think it opens up from about 5 o'clock to about 7 o'clock, maybe 6. You can get a meal up there, and pretty much once that's all finished up, from about 8 or 9, when the sky starts to get dark, there'll be a tour of the sky. I don't know who runs that now, but somebody will get a group of people together, sitting on chairs out in the field, and with a laser pointer will take you through a tour of the heavens above, and explain the various constellations and all that sort of thing. I think that still happens. Anyway, that's the sort of thing that happens, and the people are stay awake or well and truly active till 3 or 4 o'clock in the morning with their telescopes. There'll be lots of astrophotography. There'll be a whole bunch of telescopes set up in the astrophotography area, and it's really quite an amazing place, because if the weather's a little on the warm side, being out there in the open for most of the night, there's a very nice atmosphere, because you can hear everybody talking, and all these little red lights everywhere. It's quite an atmosphere to be amongst, that's for sure. I haven't been up there for a long time, actually. I should make a surprise visit. Anyway, there it is, the Starbecue for 2025. Check it out on the ASV website if you're interested in going up there for more information. You're tuned to ASV Radio, VK3EKH, the official station for the Astronomical Society of Victoria. As we all know, there's been some incredible sun activity, solar activity. For those that had a chance to see the Aurora Australis this week, there were certainly some good views on Wednesday. I didn't see it myself, but there's certainly plenty of footage and pictures of the Aurora down this way. I haven't got anything particularly to show, actually, but you can take my word for it that it was a good show on Wednesday night, apart from the AC/DC concert in Melbourne. And I might add that I was actually in Melbourne, not for the AC/DC concert, but I actually went in to the ASV monthly meeting, which I must admit I forgot to mention last Friday about it. But this Wednesday just gone, the Astro Talk, we had a presentation by a Jackie Bondal. She was talking about 10 years of gravitational waves, from Einstein's prediction to a new era of astronomy. 10 years of gravitational waves. Jackie Bondal, an ARC Centre for Excellence for Gravitational Wave Discovery, and let me see if I can if there's a bit of a blurb on her under the calendar. Just let me see if I can find if there was anything more detailed information on that. Where are we? What was the date? 12th, was it? 12th. Yeah, okay. Here we are. Okay, so what can I read here? This November, join the Astronomical Society of Victoria for an incredible journey through space, time and discovery. It's been 10 years since gravitational waves were first detected, confirming one of Einstein's greatest predictions and opening a whole new window into the universe. Jackie Bondal will guide us through how this groundbreaking field has transformed astronomy. What scientists have learned from a decade of detections and where the search for gravitational waves will take us next. Don't miss this fascinating Astro Talk that blends cutting-edge science with the wonder of discovery. Now that was last Wednesday. Now if I apologise for not reading that out last Friday, just because he could have, been more educated going to the Astro Talk at the National Herbarium than going to ACDC, seeing that in concert. But anyway, I was there. I came in half an hour. I actually went there to pick up a couple of things, but I haven't been to the actual meeting at the Herbarium for quite some time, and it was nice to get to show up and to come in on her presentation. Having said all that, I'm certain, I haven't checked, but I'm certain that the presentation would have been recorded because it goes out over YouTube. So if you go to the ASV's website, YouTube website, Astronomical Society of Victoria on YouTube, you'll most likely find the recording that was made of the presentation last Wednesday. So I'm not sure exactly how well it's come across, but it'll probably be there. I should check that. Anyway, so there it is. Okay, this is VK3EKH. Now, I've got a nice little picture of a CME here. I think some of you might have seen this one before. It's an old sort of a picture. But the article goes, it is titled, Astronomers See a Massive Stellar Explosion. Astronomers see a massive stellar explosion. This discovery marks the first confirmed sighting of a coronal mass ejection on another star. Published November 13, 2025, astronomy.com. And of course, this picture that I've got on the screen right now, a coronal mass ejection occurred August 31, 2012. As this long filament of Sun's atmosphere erupted into space, it travelled at 900 miles per second. But fortunately, in a direction away from Earth. So that's a genuine picture, what you're seeing there, genuine coronal mass ejection. And the article here is a coronal mass ejection, CME, is an eruption of gas and plasma from the Sun. Solar physicists record a number of them each year. Fortunately, most head into space in directions away from Earth. When one does encounter our planet, it can cause geomagnetic storms, which displays of aurora and even disruption or damage to communications and electrical power grids. If a planet were close enough to our star, a powerful enough CME event would even strip its atmosphere away. And while they may be common to the Sun, astronomers had never confirmed seeing one on another star until now. Using the European Space Agency's XMM Newton Space Observatory and the LOFAR telescope, LOFAR, a research team has spotted a non-solar CME. Astronomers have wanted to spot a CME on another star for decades, says Joe Callingham of the Netherlands Institute of Radio Astronomy, Astron, author of the new research published in Nature. Previous findings have inferred that they exist or hinted at their presence, but haven't actually confirmed that material has definitely escaped out into space. We've now managed to do this for the first time, says Joe Callingham. As a CME travels through the layers of a star and out into space, it produces a shock wave and also a burst of radio waves. This short, intense radio signal was picked up by the team, which identified it as coming from a star 40 light years away. This kind of radio signal just wouldn't exist unless material had completely left the star's bubble of powerful magnetism, adds Callingham. In other words, it's caused by a CME. So what kind of star is it that we're talking about? The particular star observed is a red dwarf, the most common type of star that generates energy through nuclear reactions in its core. These stars have maximum temperatures of about 3,600 degrees Celsius, with no more than 60% of the Sun's mass and 10% of its brightness. Most of the exoplanets so far discovered orbit this kind of star. The radio signal was spotted using the Low Frequency Array (LOFAR) radio telescope thanks to new data processing methods developed by co-authors Cyril Tassi and Philippe Zaka at the Observatory of Paris. The team then used the ESA's XMM Newton to determine the star's temperature, rotation and brightness in X-ray light. This was essential to interpret the radio signal and figure out what was actually going on. We needed the sensitivity and frequency of LOFAR to detect the radio waves, says co-author David Congin, a PhD student working with Joe at Astron. And without XMM Newton, we wouldn't have been able to determine the CME's motion or put it in a solar context, both crucial for providing what we'd found. Neither telescope alone would have been enough. We needed both. The researchers determined the CME to be moving at 2,400 kilometers per second. Only about 5% of the Sun's CMEs travel at this speed. The ejection would have been both fast and dense enough to completely strip away the atmospheres of any planets near the star. The atmosphere stripping ability of the CME can tell us a lot about the possibility of life on other worlds. Scientists believe a planet can sustain life if it sits within the star's habitable zone. This is a distance where liquid water can exist on a planet's surface. But if a star has frequent eruptions of powerful CMEs, and nearby worlds could lose their atmospheres. This work opens up new observational frontier for studying and understanding eruptions and space weather around other stars, adds Henrik Eland, an ESA research fellow based at the European Space Research and Technology Centre in the Netherlands. We are no longer limited to extrapolating our understanding of the Sun's CMEs to other stars. It seems that intense space weather may even more extreme around smaller stars, the primary hosts of potentially habitable exoplanets. This has important implications for how these planets keep hold of their atmospheres and possibly remain habitable over time, he said. XMM Newton is now helping us to discover how CMEs vary by star, something that's not only interesting to our study of stars and our Sun, but also our hunt for habitable worlds around other stars, he says. It also demonstrates the immense power of collaboration which underpins all successful science. The discovery was a true team effort and resolves the decades-long research or search for CMEs beyond the Sun. Yes, every light you see in the sky is a sun of various degrees and mass and size and colour and temperature. It's amazing, really is amazing. You're tuned to ASV Radio, VK3EKH, time is 10:29. And next on the list here is something about Pluto, and the graphic that they've got here for that looks a bit like this. And what they're saying here is, did Pluto's gravity affect the trajectory of New Horizons when it flew past? Pluto did both bend and accelerate the path of the spacecraft, but only very slightly. Published November 3, 2025, Astronomy.com. It's actually a question being asked. As New Horizons passed Pluto in July 2015, did the dwarf planet alter the probe's trajectory? Pluto did, in fact, both bend and accelerate the trajectory of New Horizons when the spacecraft reconnoitered with the dwarf planet in 2015, but only very slightly. There are three reasons the trajectory changes caused by Pluto were so small. One was that the spacecraft flew by fairly far from the world, about 10 Pluto radii, or 11,880 kilometres. Another reason was that the spacecraft's very fast speed at 14 kilometres per second, which is 10 times more than Pluto's escape speed. Finally, there was Pluto's low mass and therefore low gravitational influence. All three factors conspired to reduce Pluto's influence on the New Horizons trajectory, resulting in a directional change for the spacecraft of a small fraction of a degree. Had we gone closer, or even flying slower, the change would have been greater. But it's worth adding that despite the change being small, it still had to be very precisely calculated and measured, and then factored into the trajectory change we made a few months later with the spacecraft's propulsion system to target a flyby of the Kuiper Belt object Arrokoth in 2019. Had we not taken that into account, we would have considerably missed the aim point for Arrokoth, Arrokoth. It's a quick article. I like quick articles. But yes, New Horizons, it's a wonderful spacecraft that finally took some beautiful images of Pluto. We finally now know what Pluto looks like, and as far as I'm concerned, Pluto is still a planet, not a dwarf planet. But that's, my opinion. You're tuned to VK3EKH, ASV Radio. The next article is to do with Wolf-Rayet stars. Are any Wolf-Rayet stars observable with a small telescope? There are only a few hundred of these young, massive, bright stars known in our galaxy, and yes, some of them are visible in your telescope. Published November 10, 2025, Astronomy.com. And this is a picture of a Wolf-Rayet. Where are you? There it is. That's that little object in the middle of the picture there. The question is, I'm fascinated by Wolf-Rayet stars and want to know more about them. Are some of them observable with a small 4-inch telescope? Wolf-Rayets, that is WOLF, Wolf-Rayet, R-A-Y-E-T-S, Rayet. Wolf-Rayets, or WR for short, are hot, young, massive, luminous stars with vigorous stellar winds. They are also very rare. Astronomers have identified only a few hundred in our galaxy and estimate the Milky Way may hold as few as 1,000. Despite these low numbers, Wolf-Rayet stars play an important role in the galaxy's physical and chemical evolution. Wolf-Rayet stars have typical masses around 20 times greater than the Sun and probably represent the last stage in the evolution of massive O-type stars. Wolf-Rayet stars likely end their lives as either a type IB or IC supernova, which also are associated with gamma-ray bursts. Long before these stars explode, They leave their imprint on the stellar medium. Their high surface temperatures, 50,000 kelvins and up, and luminosities around 100,000 suns greater, drive stellar winds as fast as 2,500 kilometers per second. Such winds remove up to 2/3 of the star's original mass, and throughout the lifetime of the WR phase, release kinetic energy comparable to the amount produced by a supernova explosion that follows. Some Wolf-Rayet stars occur in binary star systems, so in these cases, transfer to a close stellar companion may help them lose mass too. The most distinguishing characteristic of a Wolf-Rayet star is its spectrum. In 1867, this is what caught the eyes of French astronomers Charles Wolf and Georges Rayet, who first described these peculiar stars while using a visual spectroscope at the Paris Observatory. Hydrogen is absent in nearly all Wolf-Rayet spectra because stellar winds have stripped the stars of their hydrogen envelopes. What's left is essentially a bare stellar core, rich with helium, carbon, and other products of advanced nuclear burning. Because these elements also are being thrown off by stellar winds, Wolf-Rayet stars enrich the space around them with heavier elements. Observers in the southern hemisphere and at low northern latitudes easily can see one Wolf-Rayet star with the naked eye. It's called Gamma 2 or Y2 Velorum. Part of a well-known multiple star system, Gamma 2 Vel shines at magnitude 1.8 in the constellation Vela and lies about 840 light years away. The star is really 2, a Wolf-Rayet star and its brighter type O companion. The two wheel about one another, the two revolve about one another every 78.5 days, separated only by about the distance between Earth and the Sun. The two cannot be resolved as individual stars in a telescope. The brightest Wolf-Rayet star visible to everyone in the northern hemisphere is 6.7 magnitude and is known as HD 190918, also known as SAO 69402. Oh, that's right. And numbered 133 in the catalogue of known Milky Way Wolf-Rayet stars. WR133, which also has an O-type companion star, is associated with NGC 6871, a young open star cluster located near the centre of the cross in Cygnus. And that's the end of that article. So that in that image you're seeing on the screen there, that bright blue star is Gamma 2 Velorum. Stands at the centre of this starry shot of a small region in the constellation Vela. Visible to the naked eye, Gamma 2 is a multiple star system containing a Wolf-Rayet star, although it cannot be separated in a telescope. At left is glowing nebulosity from the Gum Nebula. Nebulosity. I'm not saying that right. Nebulosity. Anyway, it's a beautiful picture, that, isn't it? When I get my observatory set up, I'm going to try and resolve those two objects. Yeah, I'm going to try and do that. Anyway, dear. All right, you're tuned to ASV Radio, VK3 Echo Kilo Hotel. Let me just check my email, see if anybody has sent me emails. In fact, I haven't got the email open, so let me just open the email, vk3ekh@gmail.com, and see if anything has come through. Mr. De Kaiser is listening. G'day, John. I caught up with John on Wednesday night. Don't see any other email there. Howdy doody, John. All right, and now if I go to Discord, let me just see if there's anybody watching on Discord. Yes, we have Andrew, VK3KIS, Cassiopeia, Nebs, and Mitch, VK3 Zulu Tango, and Steve, VK3SPX. G'day, chaps. Just a quick look at the chat room. G'day, Bruce. And Bruce is there, and that's from last week, I think. Okay. Alrighty then. Now, next on the list to go through tonight is... Oh yes, I put this off. I was going to read this one out last week. I don't think I did, actually. I can't remember, to be honest. This is courtesy of sciencealert.com. I can't remember if I did read this out last week. I just don't. I might have made it as an introduction and said I'll read the rest of it next week. Anyway, this is an interesting picture. What are we seeing here? This is published the 30th of October, and the article is titled "A Giant Radio Map Reveals Our Milky Way in a Whole New Light." Oh, I can't remember if I talked this out last week or not. Anyway, the Milky Way is a rich and complex environment. We see it as a luminous line stretching across the night sky composed of innumerable stars. But that's just the visible light. Observing the sky in other ways, such as through radio waves, provides a much more nuanced scene, full of charged particles and magnetic fields. For decades, astronomers have used radio telescopes to explore our galaxy. By studying the properties of the objects residing in the Milky Way, we can better understand its evolution and composition. To reveal the radio sky, we use the Murchison's Wide Field Array, a radio telescope in the Australian outback composed of 4,096 antennas spread over several square kilometres. The array observes wide regions of the sky at a time, enabling it to rapidly map the galaxy. And this image you're seeing on the screen at the moment is the Milky Way's galactic plane in radio light. The Milky Way's galactic plane in radio light. And there's a small video that I'll just run here in the background while I read out this article. It goes for 35 seconds, but I'll put it on a loop while I'm doing it, and there's no audio associated with it. Don't think there is. I'll just kill that just in case there was. Alright, back to the article. Between the year 2013 and 2015, the array was used to observe the entire southern hemisphere sky for the galactic and extragalactic all-sky MWA or GLEAM, GLEAM survey. Right. The survey covered a broad range of radio wave frequencies. The wide frequency coverage of GLEAM, GLEAM, which is the galactic, extragalactic, all-sky MWA, gave astronomers the first radio colour map of the sky, including the galaxy itself. It revealed the diffuse glow of the galactic disk, as well as thousands of distant galaxies and regions where stars are born and die. With the upgrade of the array in 2018, we observed the sky with higher resolution and sensitivity, resulting in the GLEAM, GLEAM, extended survey and GLEAM X. The big difference between the two surveys is that GLEAM could detect the big picture but not the detail, while GLEAM X saw the detail but not the big picture. To capture both, our team used a new imaging technique called image domain gridding, gridding, God. We combined thousands of Gleam and Gleam X observations to form one huge mosaic of the galaxy. Because the two surveys observed the sky at different times, it was important to correct the ionospheric distortions. Shifts in radio waves caused by irregularities in Earth's upper atmosphere. Otherwise, these distortions would shift the position of the sources between observations. The algorithm applies these corrections, aligning and stacking data from different nights smoothly. This took more than 1 million processing hours on supercomputers at the Pawsey Supercomputer Research Centre in Western Australia. The results is a new mosaic covering 95% of the Milky Way's visible from the southern hemisphere, spanning radio frequencies from 72 to 231 megahertz. The big advantage of the broad frequency range is the ability to see different sources with their radio colour depending on whether the radio waves are produced by cosmic magnetic fields or by hot gas. And of course that's this image that I showed before, this one here we're talking about, that one there. The emission coming from the explosion of dead stars appears in orange. The lower the frequency, the brighter it is. Meanwhile, the regions where stars are born shine in blue. These colours allow astronomers to pick out the different physical components of the galaxy at a glance. The new radio portrait of the Milky Way is most sensitive, widest area map at these lower frequencies to date. It will enable a plethora of galactic science, from discovering and studying faint and old remnants of stars' explosions to mapping the energetic cosmic rays, the dust and grains that dominate the medium within the stars. The power of this image will not be surpassed until the new Square Kilometre Array Low Telescope is complete and operational, eventually being thousands of times more sensitive than with the higher resolution than its predecessor in the Murchison Wide Field Array. This upgrade is still a few years away. For now, this new image stands as an inspiration or inspiring preview of the wonders of the full Square Kilometre Array Low will one day reveal. Yes, what they're doing out at Murchison in Western Australia is pretty amazing stuff. Keep your eyes tuned to that one. All right, we're now segueing onto the Seven Sisters. Let me see, what time have I got? Yeah, all right, we still might be able to get through this one. I think we've all seen this group of stars before. Seven Sisters, or the Pleiades star cluster, has thousands of stellar siblings, telescopes reveal, courtesy of the ABC News Science tab. The Pleiades, or Seven Sisters star cluster, is one of the most iconic features in the night sky. While the cluster contains 6 to 7 bright blue stars that can be seen by the naked eye, it's actually surrounded by a huge hidden stellar family. That's according to new research out of the US, which used data from 2 large telescopes to find thousands of siblings of the sisters. The study, which was published in the Astrophysical Journal, means the cluster is 20 times larger than previously thought. For astronomers, the Pleiades is one of the best studied clusters of stars. but it is also important in many cultures around the world, including Indigenous Australia and the Maori cultures, and has been depicted in books and art science the Bronze Age, since the Bronze Age. The Pleiades has been recognised by human cultures for thousands of years. It appears in mythology and folklore from around the world. Andrew Boyle, an astronomer at the University of North Carolina, said, "It's remarkable that this same group of stars is also one of the most important clusters for modern astrophysicists. While many stars, including our Sun, are born into lightly gravitationally bounded groups of stars called clusters, most don't stay together. Eventually stars start to drift apart, which is known as dissolving these groups. As time passes, the gravity of the galaxy passing objects in space push and pull on the group of stars and break them apart. But once clusters have begun to dissolve, it's extremely hard to work out what they originally looked like, or which stars belonged to which cluster. Part research tried to work out which stars may have been part of the Pleiades cluster by using the location and the direction of the stars were moving in, and trace them back to where they started. The Pleiades is one of, if not the most well-studied group of stars that exists," Mr. Boyle said. But because the Pleiades is surrounded by thousands of unrelated stars, it's difficult to isolate true cluster members using position and motion alone. So instead, the team combined data from two space telescopes, the European Space Agency's GEA telescope and NASA's TESS telescope, to look at the Pleiades cluster and surrounding stars in more detail. The team first used the GEA telescope, GEA telescope, to gather precise information about where the stars were and how fast they were moving to identify potential cluster siblings that had drifted away from the Seven Sisters. Then the TESS telescope, TESS, provided data on how quickly each star rotated, which allowed the researchers to drop any stars that were too old to be a part of the Pleiades cluster. Stars can start their life spinning quickly, but slow down as they age. Because Pleiades is a relatively young cluster of stars that spin fairly fast, completing one rotation in just 12 days. Any surrounding stars that look longer to rotate could be ruled out of the cluster. Tim Bedding, a University of Sydney astronomer who was not involved in the study, called the technique very clever. If a star has a rotation period of faster than 12 days, it must be young, Professor Bedding said. Therefore, it's most likely to be a member of the Pleiades complex. And here is another image. Where are you? Where are you? Dude, where are you? I didn't move it across. I can't see it. Why did I bring it across? Just stand by, gentlemen and ladies. I do have this image here. Browse. Is that it? I think that's it. Bring it across. Drop it in. Bring it up. There she blows. Okay. There it is. All right. So what we're seeing in this image, this is the overall Milky Way. This is the view of the Pleiades from Sydney, Australia, in 2025. And you might be able to make it out, but there's a little green dot just at the bottom of that image, a little green dot surrounded by a bunch of stars. That green dot in this is actually the Seven Sisters that we're talking about. The Seven Sisters cluster is shown in green, with the greater Pleiades complex shown in white. The research discovered 3,091 stars that fit the bill, spread across the sky, and determined that this larger group, the greater Pleiades complex. It covers the whole sky. You can see it spread across from horizon to horizon, Professor Bedding said. Good grief. So it shows that once again things are more complicated than we thought. Mr. Boyle said the research team was now looking at whether they could expand this new method of finding clusters to other groups of nearby stars. Astronomers have been able to identify hundreds of new groups of stars, but they say, I think it remains to be seen how many of these groups of stars are actually truly independent. The Pleiades structure we found links together at least 6 of these independent groups of stars. So, next time you look up at the Pleiades, the Seven Sisters, you'll know a little bit more about them. Oh dear. Where's my camera? Where is my camera got to? There it is. Hang on. Struth. Right, back to me. Alright, now we're coming up to the hour. I knew I'd still be able to fill up this hour easily enough. What else did I have here? Mount Burnett. The Mount Burnett Observatory, MBO. They've got a public night viewing on the 6th of December. Actually, I've got a slide for that. Let me bring up the slide. So, yes, Mount Burnett Observatory up in the hills, making the wonders of the astronomy accessible to all. So, like I say, there's a public viewing night, 6th of December. And yep, so more information about Mount Burnett if you wish to pop in and visit up there. They generally meet every Friday night. Just go to the website mbo.org.au, www.mbo, Mount Burnett Observatory, MBO, it's just mbo.org.au. Next is, no, I keep clicking the wrong thing, space weather. Good. Okay. Spaceweather.com. Let's have a look at the current disk of the sun. Not particularly active right now. There's only just a handful of sunspots there. Excuse me. If we were able to look at the sun right now, that's what it should look like roughly. And the coronal hole is producing lots of high energy particles. So let's just start off by saying that the solar wind is currently at 589.3 kilometres a second at a density of 1.73 protons per cubic centimetre. The sunspot number is 104, and the radio flux is currently, it's somewhere there in front of me. Where is the solar flux number? Radio. There it is, way down there. The radio sun, measured at a wavelength of 10.7 centimetres, is currently 156 solar flux units. And of course, the aurora over the South Antarctica is looking like that at the moment. So it's not much to write home about. The last couple of days has been red hot, but right now it's just a very, very vague green glow with about less than 1% possibility of seeing anything. So it's very faint at the moment. Interestingly enough, with all the solar activity that's been occurring in the last couple of days, last 48 hours or so, has produced some incredible propagation on 6 metres. 6 metres has been wide open to Europe and other places, and I know a bunch of local hams have made good use of that. FT8's been absolutely going crazy, making contacts right across the globe. So I think we can attribute that to this current activity, or at least related to it to some degree. What else is there in this group? KP index, the planetary K index is 1.67. Over the next 24 hours, it'll go up to 5, KP of 5, which is considered storm. Spaceweather.com is saying that, what are they saying here? The Armistice Day storm is over. After 2 full days of widespread auroras, the Armistice Day geomagnetic storm is over. The storm began on November 11 when a pair of closely spaced CMEs hit Earth, then continued on till November 12 with the arrival of the third CME. Peak levels registered severe G4 with many hours of strong G3 as well. Auroras were seen in all 50 US states, And I think that's about it, really. So the next thing I was going to show in regards to this was our current... Why has it done that? Oh, sorry, I've got a frog in the throat happening here. I'll go to this graph. Okay, this is the cosmic ray detection every other day, if it's not every day. Let me go back to the text. Cosmic rays. The solar cycle 25 is obviously now peaked and now going down the other side, and this is reflected. This is reflected in the number of cosmic rays entering the Earth's atmosphere. Neutron counts from the University of Oulu's Sodankila Geophysical Observatory show that the cosmic rays reaching are slowly declining as a result of the increased solar activity. And of course, the chart is what's on the screen right now. It's still a 30% decline. And there was something else I was going to. I was going to show this. For some reason, my chart. Where have we gone here? I don't know if I can. Wouldn't bother you. I can't get the chart up the screen there to move to its current sitting. Anyway, the one below it's pretty accurate. The solar cycle, which is in the radio wavelength, 10.7, is where you see the peak of solar 25 has been and gone, and we're now definitely on the decline. And the top one is the solar cycle from sunspot count, but I've for some reason the chart's moved off the screen there, and I can't seem to get it back. Oh, hang on. There we go. Oh, now I got it. Yep, it's one of these activated charts. We just muck around with the cursor on it. Anyway, so there it is. There's the solar cycle sunspot number at the top and the radio sun below that. And you can see how they're very, very closely related information. But it clearly indicates that we've reached the peak there, and it's now at the 1:30 position on the dial. I think that's about it. I don't think there's anything more to say in there. Yeah, in regards to that cosmic ray image here, what they say here is that almost once a week, spaceweather.com and the students of the Earth to Sky calculus fly space weather balloons in the stratosphere over California. These balloons are equipped with sensors that detect secondary cosmic rays, a form of radiation from space that can penetrate all the way down to Earth's surface. Our monitoring program has been underway without interruption for 10 years, resulting in a unique data set in situ of atmospheric measurements, which you can see on the chart there. The latest results, as of November 2024, atmospheric radiation is sharply decreasing in 2024. Our latest measurements in November registered a 10-year low. So what's going on? Ironically, the radiation drop is caused by increasing solar activity. Solar cycle 25 has roared to life faster than forecasters expected. The sun's strengthening and increasing tangled magnetic field repels cosmic rays from deep space. In addition, solar coronal mass ejections, CMEs, sweep aside cosmic rays, causing sharp reductions called the Forbush decreases. The two effects blend together to bring daily radiation levels down. So who cares? Well, cosmic rays are surprisingly down-to-earth form of space weather. They can alter the chemistry of the atmosphere, trigger lightning, and penetrate commercial aeroplanes. According to a study from the Harvard T.H. Chan School of Public Health, crews of aircraft have higher rates of cancer than the general population. The researchers listed cosmic rays, irregular sleep habits, and chemical contaminants as leading risk factors. A number of the controversial studies go even further, linking cosmic rays with cardiac arrhythmias and sudden cardiac death. Well, how about that? On a technical note, the radiation sensors on board the helium balloons detect X-rays and gamma rays in energy ranges between 10 kilo electron volts to 20 million electrovolts. These energies span the range of medical X-ray machines and airport security scanners. They say here that data points in the graph labelled stratospheric radiation correspond to peaks of the what they refer to as the Regina-Hofzer maximum, which lies between 67,000 feet above central California. When cosmic rays crash into Earth's atmosphere, they produce a spray of secondary particles that is most intense at the entrance to the stratosphere. Okay, I'll read that's enough of that. So yeah, that's an interesting chart there, and I've got a little cosmic ray detector on my table here that's been going crazy for several weeks since I've had it. In fact, I've now registered I think it's about 18.5 million hits or strikes, but that's another story. All right, let me get back to camera, and we'll disappear from here. So at 5 minutes past 11, we shall now go across to the frequency 3541 kilohertz and see if any stations are there wishing to check in for tonight's callback. As such, let me just make sure my pen is working, and I'm hoping I can see my streams are still working. Discord is still working, YouTube is still working, but as soon as I start PTTing on 80 meters here, I might lose the stream. So if the video suddenly stops, that's because I'm interrupting the modem. Anyway, this is VK3 EKH listening on 3541 for any stations wishing to check in. Sorry about that, chaps. Alright, I had to take my headphones off. Now, there were a whole bunch of stations that came up all of a sudden, so I didn't really catch any call signs, but I got Andrew, VK3KIS. So who was the first station that checked in? All right, now I thought I heard Britt. VK3AOB, VK3... I'll go with the list I've made here. VK3AOB, VK3KIS, VK5KKT. Is there any other stations? Okay. Across to you there, Britt. I did hear you call in, but I just wasn't too sure. VK3AOB, VK3EKH.
Yes, I wasn't around last week, and I think it was too cold the week before. But there you go. Anyway, job well done. VK3 EKH, VK3 AOB.
Yeah, no worries, Brett. Just out of interest, what's the signal like up there this tonight?
Very good. Yeah, just a hint of overdrive in yours, but that's okay. Just nutty a bit. I've got the RF gain wound back so that you're just on strength 9, no preamps, and I've got a lot of lightning and stuff happening that I'm hitting.
I can hear it.
And if I do that, I get rid of most of it. But your signal is, the preamps on your plus 40, nearly 50 dB. So I switched all that off and went deaf from the receive side, and anyway, the audio is good, sounds very nice. So back to you.
Good, thanks, Brett. Right, I'm trying to feed back a little bit of the audio over my digital streams. Just making sure the levels here. Looking at my level on the vMix, it's a bit peaky. I might see if I can just drop that back a little bit. 1, 2, 3, 4, 5. Just a fraction. 1, 2, 3, 4, 5. A little bit more. Yeah, that might be okay. I was just clipping that into the red because that tends to make the audio level on YouTube a little bit distorted as well. I've got to keep an eye on that. But yeah, all right, no worries, good. As soon as I start speaking up, it goes into the red. Anyway, yeah, thanks for that. I never use any preamps on the low bands. 160 and 80 meters. I don't think there's any point in having preamps running. There's so much band noise there anyway. Yeah, you're hovering around 30 over 9, so not a bad signal indeed. Okay, I'm not having the internet available there for a little while. That would be a bit painful, I'm sure. It would be for me. Oh dear. Yeah. Yes, there's a little bit of storm activity happening over Western Victoria at the moment. That's all this rain that's heading this way through the night. By about midnight, it should be hitting Melbourne, I would say. But the Bureau is saying that by morning it should be all cleared up. So we should, like I said at the beginning, we should have a relatively good day tomorrow, hopefully. Anyway, thanks for the kind comments on tonight, and I think the broadcast went reasonably well tonight, and the articles I think were relatively interesting, more or less. Anyway, okay, thanks, Brett. Across to Andrew, VK3 KIS, VK3 EKH.
Disappointed to see Aurora this week. The one evening I did 400 pictures and not a single Aurora or hint of Aurora in the pictures. And I packed up in disgust at about 10:30, and the next morning I heard the Aurora arrived at 11, so missed it by half an hour. So rather disappointed with that. But yeah, I hope all is well with you. And I was wondering about going up to the Dark Sky site at some point. I know they've got the telescope that's wheelchair accessible, but I guess the details of getting there is on the website, the Leon Mail website. Over.
Audio. H. I think Andrew, once you book, these days they want you to make a booking so they get an idea on the numbers that are going up to to the Star Party. And I think that once you go through the process of booking and confirm that you've got this ticket and all this sort of stuff, I think the information about where the site is given to you. So in general, they, as far as I know, they still try to keep the location of the Leon Mao Dark Sky site as quiet as possible. But I can tell you where it is. If you're heading up there, I can send you an email and let you know where it is through an email. That'll make that easier for you. It's it's not too far from Ladies Pass, is all I can say. If you know where Ladies Pass is, up there on the Northern Highway. Anyway, I can tell you where it is, but I'll do it offline, so to speak. 13th of December is the Star Party. So more than welcome to head up there. But look, like I say, check the website out, the ASV website. They've got the information there about the Star Party, and I think once you click on that to make a booking that you're heading up there, everything's revealed one way or another. I think that's how it works. QSL, as they say, VK3KIS, VK3EKH.
Okay, no worries there. Good to hear that. I just need to arrange carers and drivers and times, and without having enough information, I can't get the resources set up, so it's kind of catch-22. But thanks. I'll look out for your email and treat it with the right amount of discretion. Anyway, 7-3, mate. Thanks for doing it. VK3EKH, VK3KIS, 7-3.
Yeah, no worries, Andrew. VK3KIS, VK3EKH, replying, not a problem at all.